To Mrs. O'Graham's Math, we are doing another vectors question. This is from the Summer 19 question paper 31, and it's question 9. Take a minute to digest the question. I am going to take a pause and put some numbers onto that diagram from the information that we're given down here in the question. And we're asked to find the equation of the plane BCD. So that is this portion just here, that sort of triangle bit at the end. We want the equation of this plane. So if we can get two vectors on the plane, we can do the vector product to find the normal to the plane, and that'll give us the equation, and then we can just work out the d part of it. So two vectors on the plane are CD and BD. So these two vectors here, if we can find those two vectors, then we can find the normal to those by doing the vector product. So we would end up with that normal to both those two vectors, and hence normal to the plane. So that's what I'm going to carry on with. To get CD, we are going to do, we'll go from C back to O and then O to D. So that means that we will do OD minus OC to 105, and we'll do something similar for BD, 1 minus 1, 5. Now if we do the vector product of those two, we will end up with a normal to the plane CBD. It gives us that the coefficients of the plane are 5x minus 10y minus z equals some constant d. Now we know at least one of the coordinates that's on that plane. We can use either C, D, or B to work out what D has to be. I'm going to go with putting in C. I just like the looks of those numbers, and we'll see what D is. Is 25. No, wait, it's minus 25. So the equation of CBD, or BCD as it was put in the question, I should have done that, but anyway, it doesn't matter. So the equation is 5x minus 10y minus z equals minus 25. And if we move on with part 2, we are calculating the angle between the plane BCD, which we just worked out, and OABC. So OABC is this plane here, just the XY plane. The angle between planes is the same as the angle between their normals. So the normal for BCD is 5 minus 10 minus 1 that we just worked out in part 1. Now the normal to the XY plane, it would go straight up from here. If I try and draw this on the diagram, it's getting a little full, but it would be this would be the normal to the plane OCB. This one here. So normal to that plane means it goes in the direction of the z-axis, or k. If we're thinking in vector terms, we don't move any direction in I or j. So the normal to that plane will be 0. Hang on, IJK. So 0, 0, 1. And if we want the angle between those two planes, then we need to do the scalar product stuff on them. Easy one, because of the zeros, we get the scalar product of those two just comes to minus 1. Now we need the modulus of each of them. So if we modulus that first one, then we get the square root of 126, and obviously the modulus of the other one, the 001, is just 1. And then to get cos theta, we do minus 1 divided by, so the scalar product divided by the product of the moduli. And so then we can do inverse cos on that, so we get theta is equal to 95.1 degrees. Now the question asked us for the acute angle, so we just need to subtract that from 180. Answer of 84.9 degrees. Easy.